Okay, let me explain very quickly about linear transformation of vectors. In the original plan, this was part of the lecture of diagonalizing dynamical systems, so that's why the title says diagonalization, but we've changed our plans. So ignore the title for the time being and let us focus in the next couple of minutes on developing intuitions about linear transformation. Suppose that every week students have to take two tests, math test and music test. K1T is the score on math test and K2T is the score on music test in week T. Let me introduce two measures. One is a smartness measure, denoted as Y1, and this smartness measure is defined by 3 times the math test score plus 2 times the music test score. The idea behind this is that a smart person should be good at both math and music. The other measure is nerdiness measure, denoted as Y2, and nerdiness measure is defined by 2 times math test score minus the music test score. The idea is that if a person is good at math, then he is likely to be nerdy, but if he is also good at music, then that makes him less nerdy. I know this is a silly example, so don't take it seriously. Now let's express the definition of these two measures in the matrix form. So yt is the weak t vector of these two measures and kt is the weak t vector of the test scores, and b is the matrix of these coefficients 3, 2, 2, and minus 1. So yt is equal to b times kt. It is just a linear transformation. Consequently, kt is equal to b inverse times yt. Test scores are also linear transformation of the measures. As you know, a linear transformation is a continuous mapping. So if the vector of test scores converges to some k-bar, then the vector of smartness and nerdiness measures also converges to b times k-bar and vice versa. These two convergences are equivalent because linear transformation is a continuous mapping. Okay, so linear transformation is not such a difficult concept. Here in this example we had two test scores and two measures, so linear transformation was a transformation from a two-dimensional vector to another two-dimensional vector. So the linear transformation was represented by a 2 by 2 matrix, but the story would be exactly the same even if we have 5 test scores and 5 different measures. In that case, the linear transformation would be a transformation from a 5-dimensional vector to another 5-dimensional vector, and such a linear transformation would be represented by a 5 by 5 matrix. But the intuition is the same.